Today I'll be discussing Alice in Wonderland syndrome and its effects on the brain. So let's start with what is Alice in Wonderland syndrome. It is a rare condition that alters the way an individual perceives the world and distorts visual perception. Although it is temporary, it may cause people to view objects either much smaller than they actually are, known as micropsia, or bigger than they actually are, known as macropsia. It also alters the perception of how close or far an object is, and it can change one's perception of time. It is mainly seen in children, and it tends to go away as time goes on. There are 3 different types of Alice in Wonderland syndrome. The first one being type A, which mainly affects the nervous system. So this could be any weird sensation, auditory senses, or lack of coordination. Type B, which affects the visual senses for the most part. So this would be like micropsia, macropsia, metamorphopsia being a visual defect that causes objects that have lines on them to look curvy or rounded. And then type C is just a mix of these 2 symptoms together. So how is Alice in Wonderland syndrome actually diagnosed? It is typically very difficult for doctors to actually diagnose the syndrome because there are other viruses, infections, and syndromes which have similar symptoms. So usually what they would do is try to rule out any other possibilities, and they'll do this by conducting an MRI scan, which creates highly detailed images of the brain, an electroencephalography, which measures activity that is happening in the brain, and blood tests, which will help rule out any other infections or viruses. What are the causes of Alice in Wonderland syndrome? It is not specifically known what the exact causes are, but these are the most common ones. The most recurrent one being migraines. Typically, a patient will claim that they had a headache and then an hour later experience visual symptoms. Now I will be discussing 2 case studies that I found to be interesting. The first one being about an 8-year-old child who had 3 short episodes of micropsia, telopsia, along with dysmorphopsia, fever, and a headache. And he had no irregular medical history except for night terrors. And his family history also did not have any epilepsy, migraines, or other neurological conditions. And there was an EEG conducted, which is the image shown here, which showed that there was a period of 5 to 6 hertz activity in the brain, which is actually slower than normal. So this showed a correlation between Alice in Wonderland symptoms and the slower activity in the brain. The next study definitely had some interesting symptoms, and it was about a 56-year-old man who was experiencing unusual auras, which lasted around 5 minutes, and feeling like a horn was growing out of his forehead. He was aware that this sensation was not realistic, which rules out hallucination and proves that it is rather an illusion. And the man had no previous irregular medical history and only reported having migraines. The image that is shown here is of a SPECT brain scan, which shows a reduced amount of blood flow in the visual cortex. And this study shows that Alice in Wonderland syndrome is linked to functional impairment in the occipital lobe. Lastly, how does Alice in Wonderland syndrome affect the brain? Since this syndrome is very rare, there are still a lot of unknowns that scientists are trying to discover. However, these 2 lobes are what seem to be the most affected, being the parietal lobe, which has been shown that there is a parietal visual pathway which is associated with perception of where things are in space, and there's also a linked connection between parietal lobe activation and illusions about how you perceive your body. And then the occipital lobe, which could cause distortions based on how much blood flow there is in the visual cortex, and a reduced amount of this blood flow could cause micropsia, macropsia, and metamorphopsia. For these symptoms, there is an error between the cell communication, and it is still not completely known what that is, but it is clear to see that the brain does not properly process signals from the eye to the brain, And there may be an error during the transduction of visual cones, possibly when the light waves entering the visual cones are not processed correctly, and this causes an alteration in your vision. These symptoms have different causes. So, for example, micropsia may occur when fluid or blood separates the attachment of retinal cones from their underlying support cell layer, which stimulates less perceptive elements when something is visualized. And then the opposite would be macropsia, which is when retinal cones are compressed, resulting in a larger amount of stimulation. And as seen on the diagram, there is an overstimulation of visual cones in macropsia and an understimulation of visual cones in micropsia. There is also metamorphopsia, which is caused by the overgrowth of cells on the retinal membrane. This overgrowth can pull on the retina and cause the distorted vision. And that's the end. Here are my cited resources, and that's all.